Good day and welcome to the Math Salon. My name is Dr. Numendem, and thank you dear viewers for watching, and I hope that you are actually getting the help you need in preparing for your exams. I also encourage parents to do the same, to subscribe, so that when new videos are uploaded, they can actually alert their kids that there's something for them to check. Or if they have also forgotten some of the stuff, it could be a way of reminding them to also help their children better prepare for their exams. We'll look at a topic for the advanced level today, and this is binomial theorem. In order to start, I think I will just give a small recap, some ideas about binomial expansion, say, or just ordinary expansion. So normally if we have an expansion like a plus x to the power 2, normally we know that this means a plus x times a plus x. And that means a times a plus a times x plus x times a plus x times x. And if you arrange that properly, you get something like x squared plus 2ax plus a squared. See, the nice thing about it is that the first term here has no x, actually, because x is to the power 0. So I can actually write it like a to the power 2x to the power 0 plus 2 here, a to the power 1, x to the power 1 plus 1 here, x to the power let's say a to the power 0, x to the power 2. What you notice is that 2 plus 0 is 2. 1 plus 1 is 2. 0 plus 2 is 2. So it means somehow if I have an expansion like this to do, what I know is that the power of a starts with the biggest here, and this is at 0. And the a power begins to decrease as the power of x increases. And then what I'm left to know is how to get the coefficients here. Normally, if you use something like this Newton's triangle, I guess you remember it. I start with 1, then I put 1, 1. This is just for a number like a plus x. That means the coefficients are all 1, 1. A plus x squared, that's the next level. I get the coefficients are 1, 2, 1. So the third one will be 1, 3, 1, where each number is obtained as the sum of the numbers above. So 2 plus 1 plus 2 is 3, 2 plus 1 is 3, and so I can go even to this one. 1 plus that, this is 4, 3 plus 3, 6, 3 plus 1, 4. This gives me the coefficient for the expansion when it is to the fourth power. I will just choose the fourth power and we see how it goes. Say a plus x to the power 4. It says the first coefficient is 1. I write a. I put a to the maximum power, that is 4. And x to the 0, so that the sum is always 4. Plus, the next coefficient is 4. A drops in power by 1, so it goes to 3. X goes up by 1. So that each time the sum is 4. Plus, the next coefficient is 6. A again, it goes now by 1 again down. That's that, where x goes up. And that's 2 plus 2 is that. You can continue, the same. You can get that expansion. Of course, so what is interesting here is that we see how these two terms are behaving, this one and this, how they behave here in every term that is here. The coefficients for now, you can just pick them there. But if we go to something like 10, it means you need a long line here, or 20, you mean you need a longer line. And we have been able to, decode that. You can obtain this by using combination theory. So for example, if I write n combination r is defined as n factorial all over n minus r factorial r factorial. That means something like 3 combination 2. This is 3 factorial all over 3 minus 2, 1 factorial, and then 2 factorial. 1 factorial is defined as 1. So you can simplify something like that. So in general, we can write this expression a plus x to the power n as there are always plus, plus, plus. So I use this summation symbol here, r from 0 to n. The coefficients, we say they should be written like that. And now we are left only to see how these two behave. We have said that a will take the maximum power, n, and it will be in such a way that x takes a power that matches. So the idea is that the sum of these two powers always should be equal to n. So if this is n minus r, then that should be r here. So that n minus r plus r is n. So it means this is a general way we have it. In order to solve the problem that we have at hand, it says find the term in x to the power 10 in the binomial expansion this. This is a special problem to solve because we have x here and we also have x here. So it means that the x powers are going up here, they're also here increasing. But because they're below, they'll be cancelling up. So it means at one point in time, you have the x above and below cancel, that you have x to the 10. That is the term we are supposed to look for. If in this expansion this number was 1 here, then this is very simple. It means this one just goes to 1 and it remains a very simple relationship. Just n combination r x to the power r, which is really simple. See, so one of the ways is if we try to express this with 1 in this position, it can be easy. I will show you here. So this is my expression. I'm going to take this term outside the brackets, and since it is to the power 10, I have a x squared divided by 2 to the power 10. 1 remains in this position. But because it was not here, I will divide here by that one, so that if I do open, when I multiply back, it should cancel. So I put it below here. So this is my x squared that. But this, of course, can be arranged. You can make it nicely. Divided by x squared on 2 is actually 2 on x to the power 3 times 2 on x to the power 2. You just you flip it over. If you do that, then 2 times 2 is 4, and x to the power 3 times x to the power 2 is x to the power 5. And we come to this level of the expression. Hope you understand how we move from here to here. If this is true, then I have x to the power 20 outside here, and 2 to the power 10. It means all of this now, their x's will always be in the denominator. So the term where x in the denominator is to the power 10 will be the one I will take, because then when it multiplies this, the 20 above with the 10 below will make me 20 above. If we expand this binomially, then we will get, just like I said, so if you have here 1 plus x to the power n, then you are simply just going to have here 1 plus n combination 1, x to the power 1 plus n combination 2, x to the power 2, and so forth. That's what you would have. And that's what we'll try to do here. So the first term is 1. Then n combination 1, my n from the problem is 10. So n is 10 here. So that's 10 combination 1. And my term, this is what we are looking at here. So this expansion we are looking at is about this part here. So if I arrange it well, then I will say this is here plus, and I put the minus inside. See? Then I can wipe this. Then see that my x here is this one, minus 4 on x to the power 5. So if I do that, then this goes to the power 1. That's to the power 1 here, if you just want to see that. Plus 10 combination 2, it goes to the power 2, and it continues. But at this level, I already recognize that this, with this 2 here, gives me x to the power 10 below. So this is a term that I should take together with this. So I forget about the other ones and concentrate on these two. So this term is there. That's that. And this one is from inside here. So this is from here, and this is from there. So if that is true, of course this is 2 there, that's right. Then what I have to do now is I open this. So 4 to the power 2 and x to the power 10. I multiply this out. If I do, x here to the power 10 will cancel this and give me x to the power 10 there. Do I have x to the power 10? That's the only situation about x. The rest are the coefficients that I have to fix. This is 4 to the power 2 is also 2 to the power 4. And I have 2 to the power 10 below. So they cancel and give me 2 to the power 6 here. This 10 combination 2, I already indicated here. So 10 combination 2 is equal to 10 factorial divided by 10 minus 2 factorial. That is 8 factorial and 2 factorial. So I get that here. If you simplify that expression, you get 45 on 64 x to the power 10. And that is what we are looking for. There could be an alternative way of doing it. It's shorter, but we have to think a little smartly as well. So we already just learned here that I can write this x to the power 2 on 2 minus 2 x to the power 3 raised to the power 10 as the sum r from 0 to 10 combination r, the first term here, which is x squared on 2 raised to the power n minus r, I already showed you that, times the second one, which is minus 2 all over x cubed raised to the power r. But my n is 10, so I will just make it 10 here, just for you to see. N is 10. So I have 10 minus r and r. If I fix this part properly, then I would expect that this place here would be 10 here, combination r. My summation is there, r equal to 0 to n. I want to open the bracket. If I do that, I get x to the power 2 into 10 minus r and 2 10 minus r. The x can go up, becomes x minus 3. So I can write this also as minus 2 x to the power minus 3. And the minus 3, and that gives me here x to the minus 3r and minus 2 to the power r. I'm interested in the way x is behaving, not the other coefficient. So I have here x to the power 2 into 10 minus r times x to the power minus 3r. If these two x combine together to give me something as x to the power 10, it means these two, the powers have to, the sum of these two powers should be equal to 10. That means 2 into 10 minus r minus 3r is equal to 10. This means 20 minus 2r minus 3r is equal to 10. 10 comes here, becomes 10. This is minus 5r to the other side is 5r. That means r is equal to 2. So it means that the term that would have x to the power 10 is the term with r equal to 2, which means the third term. And we already saw that here, that 1, 2, that was the third term. So this is what I tried to show you here. So this is my sum here by the definition of that. So I want to make sure that the powers that link to x here and here, so this is 2 times 10 minus that, this is minus 3 because x goes up. And if you do that, you see that r is equal to 2. So I'm just left to come back into this formula and put my r equal to 2. That means the term will be 10 combination 2 x squared on 2 to the power. R is 2, so that is 8. 10 minus 2 is 8 times minus 2 on x to the power 3 to the power 2. And that's what we've just tried to do here. So that my x and this becomes 2 times 8, and this is 2 to the 8. And this is squared, so this will just change to positive. So this is 2 to the power 2, x to the power 6. Of course, they would cancel out there, and I get my x to the power 10, because here this is 16. So that is going to be 16 minus 6. And this will cancel here, and you get this form. And of course, our combination term that is there. And once again, you get exactly the same result. Hope you liked the video. And I encourage all of you to subscribe. Tell your friends, so that we know how many people are benefiting from this. Thank you. Bye-bye.